your test. Date to the last day to retake expires on Friday, November 6th. So in reteaching these two lessons, some things you need to remember about polynomials, okay? We went over this in your problem of the day. Whenever you have a fraction as an exponent, okay? Remember, that can be rewritten how? The nth root x to the p, okay? So whatever that numerator is, it stays with the x, and then the denominator is your root, is the type of radical you're dealing with, okay? And some specific things relating to the value of n. If n is even, then the domain is going to be restricted to 0 to infinity, and if it's odd, the domain is negative infinity to infinity. Yes? True, but that's not in these situations. Those are a different situation with the exponent. So when it's a fraction, here is negative infinity to infinity. But you'll see one where it actually is an infinite discontinuity at 0. Okay? So in general, we're going to talk about what these look like, okay? Here, how else could I rewrite x to the 1/2? Square root of x, because think about a 2 in here, that is what a square root represents, okay? And so if I wanted to make a quick table and plug in some values, if I plug in -2 or -1, can I take the square root of a negative number? No, you can't. You can only take odd roots of negative numbers. What about the square root of 0? See? What about the square root of 1? 1. What about 2? Square root of 2. What number is that? 1 point something. So 1 is some change. You know it's going to be past 1, but it's not going to be 2, right? So it's going to be somewhere in between 1 and 2. So if I wanted to do a quick sketch of this, I have 0, 0, 1, 1, and 2 and a little bit of change. What's the next perfect square, just out of curiosity? 4. What's the square root of 4? 2. So you can use that knowledge to help you as well to know that, there we go, we're shooting off this way. Okay? How would I do the second one? How can I rewrite this? Actually, I'm calling somebody. How can I rewrite this? Okay. Volunteer? Any volunteers? Only a few? Claire? Cube root x what? Squared. Very good. Okay? So, here, I have a question. When you square a number, what happens to it? It was negative for sure. Question? Sure? Okay. When I plug in -2, what's -2 squared? A positive 4. Can I take the cube root of positive 4? You could try. It doesn't exist. The cube root of 4, is it a number or is it undefined? It's a number. 1 and some change, okay? Remember, we're just trying to get a general idea of what these look like. When I plug in -1, what's -1 squared?
1.
What's the cube root of 1?
1.
It's exactly 1. What happens when I plug in 0? What do I get?
0.
What about when I plug in positive 1?
1.
And then when I plug in a positive 2, 1 and some change. Okay? So when I graph this, I have 0, 0, 1, 1, 2 and some change. Or sorry, 1 and some change. -1, 1, -2, 1 and some change. But this is not exactly an absolute value. It's more curved, and since I don't have like a perfect grid here, of course it's going to look kind of funky. But so remember, if you plug in 2, it should be exactly at 2, and we're at 1 and some change. Questions up to here. This is the opportunity to ask them, okay? Because you know what you got on the first standard. You have the paper, okay? I need to make sure that we address any kind of questions you have on this, or or these types of questions? Joe, how do I write this one?
The fifth root of x to the 7.
Very good. Fifth root of x to the 7, okay? And I try to give you an example of each different type, okay? Here, I had an even root, an odd in there. Here, I had an odd root and even in there. Here, I have an odd root and an odd exponent. So everybody see, I try to give you one of each so you kind of get an idea of what these look like, okay? When I make a table here, I'll plug in -2. What's -2 to the 7th power? It's going to be negative. So we have the fifth root of a -128. Can I take the fifth root of a negative number?
Yes.
Yes, you can. Remember, you can take odd roots of negative numbers. Okay? So, this one might be a little bit more challenging. I just need a general idea. Is it 1 and some change? Is it 2 or is it -1 and some change? -2 and some change? -3 and some change?
It is positive. The fifth.
But it's still a negative number though. So just like here when we were taking
Oh, so it'd be like
Is it
taking
four?
the
That's
four
like-
and
it's like
-1 it would
three
still
and
be
some change.
No,
negative.
4 and some change. Oh, why do you keep saying interest change?
4
because we don't know the exact decimal. So I'm not letting you use your calculator.
4 and some change would go above 128, so it'd be 3 and some change.
Because think about it. You're looking for numbers, okay? You're trying to figure out what number is this close to.
11.
Huh?
11.
Yeah, but that's the square root. We gotta think fifth root. What number times itself 5 times is close to a -128? Think about 2. It can't be 2, okay? What about 3? What's 3 to the 5th power? Does anybody know?
240.
Thank you with the calculator. So you know it can't be that. So it's gonna have to be 2 and some change. And it's a -2 because I'm taking the odd root of a negative number.
2 to the 5th is 32 though. 2 to the 5th is 32
Right, but
That's the closest.
that's gonna be, yeah. And think about 3 to the 5th is
out there.
bigger than that. When we plug in -1, what do we get? Plug in 0,
0.
plug in 1,
1.
plug in 2,
2 and some change.
2 and some change, okay? So you kind of have an idea again of what this looks like. 0, 0, 1, 1, -1, -1, so on and so forth. Do you see how this works? It's the time to ask the questions. Yes?
-2, y is -2, so y is
Oh, thank you. I clearly messed that up. I appreciate that. Thank you for that. Questions?
If we were allowed to use a calculator, would we actually have to get exact number, or can we still say it's doing some change?
You can just say it's still 2 and some change. Okay. Because remember, these graphs, you just need to answer the rest of those following questions. What's the domain? What's the range? Is this discontinuous anywhere? None of these are. Okay? None of these are. Questions on these types when you have a fraction in the exponent. When you just have a whole number, okay? These ones, this is one where I had you guys do the arm thing. You guys remember the arm thing from last week or the week before? Okay? If n is even, then we know the end behavior is either going to be rise, rise, or fall, fall. How do we know which is which?
If A is negative, it's positive.
If A is positive or negative, okay? When am I going to fall, fall on both sides?
Even.
Negative.
Not even negative.
When it's an even power and a negative coefficient. Odd, odd, they're opposite. Either you rise, fall, or you fall, rise. So in general, what does x to the 6 look like? Show me with your arms. Very good. It's going to be up here. Something happens in the middle. There you go. Show me with your arms. What does this look like? Very good. I have these squiggles here because something else is happening. I don't know if it indeed, like, it has extra curves or something like that. I just know that the ends look like this. What about a negative x to the 4? Show me. Good stuff. And here, show me. Okay? So you can know your respective end behaviors. Okay? These are probably the easier out of all the different types of power polynomial functions we dealt with. Questions on these? Remember, in behavior, we use limits. Okay? What are the last type of exponents? The negative ones, okay? Remember, x to the negative n is the same thing as saying 1 over x to the positive n. What number cannot be in the denominator? 0. Because if you have 0 in the denominator, it's undefined. What's happening at 0? It's an asymptote. Asymptote, Chris.
What's the rule when it's a negative fraction?
When it's a negative fraction, it flips and then you have a root in the denominator. That's a very good question. Chris asked, what if you had a negative fraction? Okay, well, it gets flipped and then you have again a radical, all right? This is the nth root x to the p. If n is even, and I'm talking about an even whole number, curves are going to be on the same side. If n is odd, curves are going in the opposite direction, like a reciprocal function. Everybody remembers what a reciprocal function looks like? Okay, so how can I rewrite x to the negative third, Isaac? 1 over x to the third, very good. And this, careful if you think it's square root. Quick table, when I plug in negative 2, what's negative 2 to the third? So this is a negative 1/8. What about when I plug in negative 1? It's negative 1 to the third power. So this becomes a negative 1. When I plug in 0, it is undefined. So there is a dotted line, asymptote, at 0. What do I get when I plug in 1? What do I get when I plug in 2? Don't forget, you can always default to making the table. You can just rewrite it, make the table, plug in points. What about x to the negative 4? How can I rewrite this, Tiana? Very good. Plug in values. When I plug in negative 2, what's negative 2 to the 4th power, Chelsea? To the 4th power. So it's going to be 1 over 16, a positive number, right? When I plug in negative 1 to the 4th power is what, Brian?
1.
So it's going to be 1 over 1, which is just 1. When I plug in 0, what happens? Undefined. Anybody, when I plug in 1? When I plug in 2? And it doesn't matter whether it's an even power, a negative power, so it can be negative 4 to negative 6 to negative 8. All of those are going to look like that. Questions? Now I just did the graph part because I feel like if you can have the graph, you can be able to find the domain, right? The range. What about if it's continuous or not?
Yes.
In behavior? If not, let me know. So for this, which one? Either one or just okay, let's do that. What's the domain here? Remember, domain is X or Y. The X is. The domain would be to 0, not including union. What's the range for this one? Say again. 0, not included, to infinity, only. Exactly, because it doesn't have any negative y's. What about for this one? Negative infinity to 0. And what about the range? The range would be like the domain. Sorry, that's a little cramped in there. Questions? This is the time to ask, you guys. Uh-huh. Exactly. Yes.
Is this run as a piecewise function?
Huh?
Is this run as a piecewise function or?
No, these are not piecewise functions. These will be ones with asymptotes, yes. Exactly, infinite discontinuity. Calculators out, okay? Now, I went over this before. This time I feel like I have to write it down because some of you guys did not write this down, okay? When you're doing data, where do you go?
Stat.
You press the stat button. And then you go where?
Edit.
Then you go to edit, and then option 1, right? When that pops up, what? You enter in your data. What goes here in L1? For this particular example, we'll go here.
Years.
The years, and we'll go in what to L2? Minutes. Now, careful. If I read over this problem, it says, graph several colors best fit. The number of years since 1930. 1930 will represent year what? 0. The initial year. So 1940 would be what? Careful. How many years from 1930 to 1940 is that?
Oh, 10.
So you start with 10. 1950 would be, and 1960, and it goes so on and so forth. The minutes was. The only issue with that is that it's asking a follow-up question in step 3, and so you want to make sure that it's true to the numbers, okay? So go ahead and get that in.
So you guys are in there by 10?
And so the reason, again, why you're entering them by tens is because it tells you which is the starting year, and you never put in 1930 or 2010. You started at year 0, okay? The only time you actually do what's true in the X column or in the L1 column is if it's talking about energy input, the months, stuff like that, okay? Once you get your data in, then what do you have to make sure of?
Plot is highlight.
The plot is highlighted. How do I get to the plot?
Y equals.
I press the Y equals button, and I need to make sure that plot 1 is highlighted. How do I make sure it's highlighted? Go up to it and click enter. Then what? How do I actually see my scatter plot?
Zoom.
Zoom, and go down to option 9, which is zoom stat. And it should show up, especially if you turned it on. Okay. How do I get these different types of equations?
You hit second mode.
Second mode, because I gotta get back to my home screen.
Stat.
You go, okay, wait, hold on. Then what?
Calc.
Go over to calc.
Then you go down to the given
Where's Lin Ray at? What option number?
8,
Here.
4,
4. Where is quad reg at?
5,
Where's cubic reg at?
6.
And the reason why it asked you to graph several of these is because you need to see which one does what? Fits it best. Now, if I tell you which one to do, which one should you do? That particular one. If I say a degree of 3, which one is that? It's a cubic. If I say a degree of 2, it's a what? A quadratic. Some of you guys didn't read to know which one you were supposed to do. Now,